Hey everyone, welcome to Tutort Academy. So my name is Chirag Vaishnav, and in this video we will be discussing the quotient linked list cycle, right? So let me first explain the flow of this video. So in this video first I will be explaining the quotient, then we will be discussing the approach to solve the quotient, and then we will be discussing the code, right? So I am definitely sure that you are really excited for this. So without further ado, let's start with the problem statement. So here we are at the problem statement. So let me first explain you that what the problem statement is. So the problem states that you are provided with the head of a linked list and you have to find if there exists a loop in a linked list or not. So now the question arises that what exactly a loop is, right? So a loop, you can say a loop is a condition where if particular node's next is pointing to a node that is already been traversed in the particular linked list, right? So it will be forming a condition of loop. So how does it basically act? So let me explain you with the help of example. So here you can see in the case of 3, 2, 1, 0 and -4, right? So first the head was at this, then it was at 2, then it was at 0, then it was at -4. After -4, if we talk about linear linked list, it should end to the next of that -4 node should point to null. But in this case, it is pointing to the node that is having value 2, right? So here the loop has been created, right? So let me explain you with the help of this, right? So I hope my screen is visible. So let's say 3, 2, let me just draw it, right? So 3, 2, 0 and -4. Cool. So these were the only nodes that we were having, right? So according to the problem, it was showing like this, right? So let's say head is here, right? So when we move to next, the head will be here. When we'll move to next, the head will be here. When we'll move to the next, the head will be here, right? But after this, the head will again point to 2. Right? After this, it will again point to 0. After this, it will again point to 4. After this, it will again point to 2. So here, a condition of the loop is being created that we are stuck here. We are revolving here and here and here. So this is the basically loop condition in the given linked list, right? So I hope it's clear now, right? So let's move back to the question. So what you have to do, you have to return true if there is a cycle of, or if there is a loop in the given linked list or not, right? If there is, you have to return true, else you have to return false, right? So let's move to the PowerPoint only so that we can further discuss that what we have to do or what we can do, right? So here you can see what we have to do. You have to find if there is a cycle or not. So first let's discuss the brute force approach. So the brute force approach will be, like this. What you have to do, you have to create an unordered map, right? So let's say 1, 2, 3, 4, 5, 3, 6, right? So let's say it's like this. I'm really sorry for that writing, right? But I will try my best to explain you this. 6 and 6 again points to this 3, right? Suppose this is the linked list. So what you have to do, you have to like traverse it and you have to create a hash map, right? So so what we will do, we will traverse and add that element, and if any time we got that particular node again, then we will see that okay, it's repeating. And why it's repeating? Because there is a cycle, we are traversing that node again, right? So here in this condition also we have discussed the same, that what was happening is after -4, if it was linear, it should the next of the -4 node should point to null, but in this case it's pointing to 2. So the same case is happening here as well, right? So what you have to do, you have to store in hash map. But one thing that you have to keep in mind, you don't have to store values in hash map. You have to store the complete node in hash map, right? Complete node means its address as well, because in the case of this, suppose first I stored 1, then I stored 2, then I stored 3, then I stored 4, then I stored 5, and then I stored 3, right? So what it should do, what it will do particularly, it will detect that okay, 3 is coming twice, that's why it's a cycle, right? So okay, let me just give you a small example. Suppose 1, 2, 3, 1, right? Suppose this was a linked list and this was null here, right? So even if it was null here, while using this approach, if we store the elements in the hash map, so if we will store the elements in the hash map, it will be like 1, 2, 3, and again 1, and as soon as it detects that there is 1 again, it will just return false. It will just return true, sorry, right? So in this case it will say that okay, there is a cycle that is being existing, but it's not, we know, right? So you have to keep the hash map for a particular node. You have to store that complete address, complete node in it, right? So that's basically the brute force approach. So in this, so you don't have to store the values, but in that particular hash map, if any of that address of that node particularly appears again, so it simply means that okay, you are in a loop, you are in a cycle, and then you have to return true, right? So this was the brute force approach. Now let's discuss the optimized approach, right? So let me just take another page. Okay. So here we are. So now what you have to do, let's move with the optimized approach. So in the case of optimized approach, first let's discuss that what is the optimized approach, and then we'll discuss that what is the logic behind that intuition particularly, right? So in a given linked list, let's say 0, -3, 4, 5, and 6, and 3 again, let's say, right? So this is a linked list, and it's pointing to 4, let's say, right? So now what you have to do, you have to find if there is a loop in this or not, right? So what we will do, we will use slow and fast pointer approach, right? So if you the slow and fast pointer approach is very applicable in the case of linked list. There are other applications as well if you want to find the middle element or the cycle or the y intersection, or a lot of applications are there, right? So what you have to do, you have to use slow and fast pointer here, right? So slow pointer will move by 1, and fast pointer will move by 2. Move by 2, right? So you have to make a slow and fast pointer move, and if there exists any condition where slow and fast pointer matches, then there will be existing a cycle or loop in the given linked list, right? So let's see that if it is working or not, right? So initially slow and fast were pointing to this only. Now slow move to this and fast move to this, right? And after this, slow move to this and fast move to this, right? After this, slow move to this and fast move to this behind here, right? After this, slow move to this and fast move to this. And here we can say slow and fast are equal, and that's why the cycle or that particular loop in the given linked list exists, and we have to return true, right? So now you can see, okay, you can just mug up that and say that okay, it's an intuition, it's working, and that's the thing, right? So let me explain you that if there are slow and fast pointer, and if there is loop existing, if the loop is existing, then it will never end, right? So it will never end, it will just got stuck and revolve and revolve and revolve around there. If the fast or slow pointer becomes null, then we have that no, we don't have any list, we don't have any loop or cycle in it, because we have got to an end. But in the case of cycle or loop, what it basically means is we are stuck there, right? So let me just explain you. Suppose if there were 2 nodes, right, and here was slow and here was fast, right? So in the next iteration, what will happen is, in the next iteration, what will slow will move to here and fast will move to here, right? So here it matches. So again you can say that okay, just to prove your intuition or prove whatever you have written, you can say that that's correct, right? So let's take another example, right? Let's take slow here, fast here, and slow here, right? So in the next iteration, what will happen is slow will move to here and fast will move to here. Again the same condition happens, and in next, slow moves here and fast moves here, and they matches. Again you can say, let's take a broader example as well. Let's say fast here and slow here. So you cannot say that I am mugging up the things, I am just doing it randomly, but I know that this works, right? So in the next, let me just remove this, right? So in the next iteration, what will happen is this will move to this, and this will move here. In the next, what will happen is this will move here, and this will move here. In the next, what will happen is this will move here, and this will move here, and again the same situation is arising. So in the next, what would happen is this will move here, and this will move here, and the slow and fast pointer will match, right? And why I'm extending these nodes, why I'm not making this null, because I am assuming that if it is a cycle or a loop, right, and if it is not, and even fast or slow pointer points to null, then this simply means that the particular linked list has came to an end, and it's a linear linked list, not a cycle, or there is no loop in it particularly. The quotient, with the help of quotient, what we are trying to say. So I hope that the intuition is clear. Now let's move to the code part to understand that how we can solve this, right? So the code is pretty simple. So what you have to do, you have to first take a slow pointer and the fast pointer. So in the example or diagram also, we have seen that we have initialized both slow and fast with the initial pointer or initial node only, right? Now when while fast or fast next and slow is not null, so till the point where the fast node or slow node or next to the fast node is not null, right? If any of these comes null, then we simply can say that it is a linear linked list and there is no loop particularly existing in this, right? And till the point that it is not going to null, we can iterate through this particular loop. So we will move slow pointer in 1, slow to slow next, and fast with 2, fast to next, right? Now if slow equals fast, if both the particular pointer is pointing to the same node, then we have to return true that yes, there is a cycle existing, and I have explained really well that how the intuition works. And if not, if we are being exited out of the loop, so we will return false, and no, there is no cycle or list in this, right? So I tried my best to explain this, right? So I hope you got that solution right. So if you're having any doubt, you can ask in the comment section. I will for sure answer it. Also, if you like this video, do give a thumbs up, subscribe to this channel, and thanks for watching.